Thank you so much, everybody. I appreciate that you're here. Thank you so much for the time. Thank you so much for making this happen, JetBrains. I really appreciate it. We don't have a lot of time. We've got about 40 minutes, as I understand it. It's now 3 after, so let's say 1:43, and that's about it. So we have to go. We have to go really quickly. There's a lot of stuff to cover, and so very little time in which to do it. So as always, I always start my presentations with a slide like this one, where I say I give my coordinates. So should you have questions, comments, feedback, whatever, you can find me. I'm on Twitter at StarbucksMan. If you have some aversion to Twitter, perhaps you'll consider email. I don't like email, but it's better than nothing, I suppose, and certainly better than Slack. So you can find me there. My name is Josh Long. I am a Spring developer advocate. I have been since 2010, and I am a newly minted Kotlin GDE Google developer expert. I love Kotlin, and obviously I thought about that actually. I should have done I'm really excited that we're going to be doing a testing talk, but what occurred to me was that this is a JetBrains show. I should do a Kotlin talk. So next time, I've got a Kotlin talk. There's a bunch of Kotlin videos out there you can find that I've done that are not going to be as good as this one, of course, but nonetheless, it's a thing I could have done. I'm also a Java champion, just like Mala and Trisha. So I count myself as very lucky to be among their numbers, and I'm a big fan of the JVM. Lots of cool stuff going on there, and hopefully as you'll see after this session, I'm a big fan of testing. I'm a big fan of what testing implies for the workflow for software. Go ahead and take note of that Git repository there, github.com/joshlong/Bootiful testing. There you're going to find the code for you to follow along. Not right now, of course. Don't do it now. Save it for later. But when you're done with this presentation, and before the next presentation has launched, please git clone that, do a maven clean install, try it out, kick the tires, etc. I work on the Spring team as part of VMware, as part of Tanzu, right? We're a division called TANZU, which is part of VMware, and Spring is part of that. As part of what I do, I get to talk to people all around the internet and all around the world. Well, historically, I've done training videos. These are on Safari. There's one, Spring Boot and Kotlin. You can find that. It's on Safari. Lots of stuff there. I've got a book called Cloud Native Java, all about how to build applications that survive and thrive in terms of Spring Boot, Spring Cloud, and Cloud Foundry. I've got a podcast. I had Mala Gupta on the podcast. This podcast is just an opportunity for me to speak to people who are smarter than I am, and so obviously it's a very low bar to be smarter than me, certainly. But I've managed to trick really, really, really smart people into joining me on the podcast. So I hope you'll listen to that. And I do a roundup every Tuesday called This Week in Spring. It's just a recap of all the news that's fit to reprint in the Spring ecosystem. And I have a screencast series every Wednesday. It's called Spring Tips, where I just look at some corner of the ecosystem, some piece of arcana in the ecosystem, and I just deep dive. And the nice thing is these are videos. You can self-select into them. If you're not interested, just click next. There's probably something you're going to be interested in. Whereas when I do conference talks, these have to be more broad scoped, right? Broad scoped as opposed to deep dive, breadth first. And of course, I've got a book called Reactive Spring, and that's that book is all about how to build applications that take advantage of reactive programming. I have a whole chapter on testing in that book, but really it's not really the same focus as what we're going to look at today, except that what we're going to do today is going to use reactive API. So everything we're going to do today is going to look at reactive code, only because it's just what I assume people are doing, absent a particular reason not to. There's Trisha did an amazing series looking at reactive Spring. She did, multiple parts. It must be 5-10 parts. It was huge. It was, I think she just finished it a few months ago. You can find that, just Google Trisha and reactive Spring. You'll find an amazing series. So you maybe don't need the book, just read her series. I certainly did. It was great. I learned a lot. So reactive programming is just a way to write software that takes advantage of threads in a more efficient way. But beyond that, we don't really need to worry about it too much, because what we're going to focus on today is testing applications. We're going to talk about testing Spring Boot applications. And in order to appreciate why we are going to do this, we have to kind of look at how we got here and what drives us to this particular destination. What we care about here is cycle time, right? That's the movement of software to production. How quickly can we go from concept to customer? Going fast, of course, is in of itself not a goal. We want to go quickly and safely, right? How quickly can I get software into production doesn't mean anything if that software is terrible. Any fool can drive a Maserati or a Ferrari into a wall at top speed. No, no, no. What we want to do is a little bit more nuanced than that. We want to learn from our experiments. We want to learn from the cycle time. That's the whole point. We want to go quickly and learn quickly. Instead, if you think about all the interesting trends in the last few decades, the overarching theme I think you'll find is that we've spent a lot of energy on reducing cycle time. Yes, there have been some absolutely amazing technological evolutions, certainly, if not revolutions. But really, the most interesting thing I have seen in the last 20 years has not been that we've introduced amazing new frontiers, but that we've made the existing frontiers, we've been able to explore the existing frontiers so much more quickly and more efficiently because we've figured out how to reduce cycle time, right? So think about that. Look at all the buzzwords. Continuous integration is all about reducing cycle time between when we introduce a bug and when we discover it through our test suite. Cloud computing is all about reducing cycle time between taking an idea and provisioning infrastructure so as to be able to supply that idea, right? The idea of an MVP, right? Getting a working minimum viable product out there for the consumer. Again, about getting cycle time lower, right? It's not because the customer wants an incomplete product. That's not the goal, right? That's not what we're looking for here. It's that we want to know whether what we're building is what the customer wants, or perhaps more usefully, what the customer needs, right? It's all about reducing cycle time so that we can learn. Microservices are the same thing. It's all about reducing the time between having a concept and seeing it released into the hands of the customer where we can validate the idea. And we do that by reducing the scope of a service to as small a size as possible, not in terms of code count, but in terms of responsibility, right? The single responsibility principle, but applied for network services. So lots of goals there. And one of these things that we've seen in the last 10, 20 years that has become more crucial is test-driven development. This idea that we're going to do testing first. That, again, seeks to reduce cycle time, right? How quickly can I see an idea go from concept to customer? So the idea is very simple, right? We want to write tests. We know that testing is a good idea. I don't think it's controversial today, unless you're doing PHP code, in which case deploy that into FTP and just see what happens. Production is fun, but basically, test-driven development is a very testing is a very good idea. We all understand the value of that. We understand that it's useful to have something to act as a harness to catch our regressions when we introduce them into our code base. I know that you, my dear audience, don't introduce bugs into your code, but I certainly do. And so I really appreciate having something like a regression harness to catch those particular mistakes. When you write production code, the goal, of course, is to then see if you've made any bugs or introduced any bugs in that production code. So that's one side of it, right? But what I really want is I want to write the tests first. I want to write the test first because there's several benefits that fall out of that. One is when you write the test first, you get a contract. You get a thing against which you can build. You have an ideal, and then you can provide the implementation that satisfies it. So it helps you clarify your thoughts around the design of a particular thing. When you write the test first, you are also, by definition, writing code that is testable. That is to say, you have to write code that supports isolation, right? The components in the code base need to be extractable and tested in isolation. That's the whole point of unit testing, for example, is that you take all the collaborating objects and replace those with mocks and so on. You can't do that if your code is not designed in such a way as to support that. Well, of course, dependency injection and Spring and frameworks like Spring, the whole point is to make it so that you can easily compartmentalize your code, and that has a natural sort of balance with test-driven development. So again, when you write testable code, you write better code, you write cleaner, more object-oriented code, etc. Okay, so there you go. So lots of benefits there. What we want to do is to take advantage of test-driven development and to go faster, right? So you write some test code first, then you write production code so that the failing test code passes, and then you only write enough production code to make the test fail again, right? or rather to make the test worth doing again. So that cycle is what you want. You want to get into a loop where you write test code, then you write production code, then you write test code, and you write production code, and you're not going to get too far, especially with a statically typed language like Java or Kotlin or Groovy or whatever. You're going to end up in a continuous loop, writing tests and writing code to make the test compile and pass, and then going back and forth and so on. So this is a nice place to be. If you're doing pair programming, which is a very common thing in the ecosystem, we have a group called Pivotal Labs. It's part of the Tanzu division. Pivotal Labs helps people modernize applications and helps them learn how to write software in a modern fashion. And part of what we do is red-green refactoring. Somebody writes, you're pair programming, two people sat, each to their own computer and monitor and keyboard and mouse, but they have the same computer. One person writes a failing test, the other person writes the green implementation code that makes the test pass, right? And that's a very nice way to go. It's somebody, you ping pong back and forth. The benefit of writing code in this way first is that also by the time you've gotten the test to go green, you've also succeeded in delivering the feature. So most of us have felt that acute sense of joy, of euphoria at having made something work. But doesn't it feel like a bit of a drag to have to then go back and make it and to have to document it and then test it, right? It feels like a chore. When you do test-driven development, you get that endorphin hit at having made something work at the same time as you make the test work. So you're done, right? You get this, it's all done for you. So you never have this drag of like, oh, okay, now I got to do the homework. Now I got to do the chore. That's not fun. Nobody wants to clean up the mess after they've had a party. That's what we're trying to do, is to make it so that the clean code gets done at the same time as the discipline, the chore gets done, right? So a lot of good stuff there. The question then, of course, becomes, why do we do, it becomes, how do we do test-driven development? What parts of the code base do we test first? And here, it sort of depends on the style. There's two different ways you can think about this, inside out or outside in. There's two different ways to think about it, right? You have to decide upon whether you want to write tests for the innermost components first, and then work your way out to the API and the UI layers, or if you want to do things in reverse, starting with the UI and then working your way inwards. The inside-out approach has sometimes been called the Chicago style, right? Here, as best as I can understand, the differences are in the approach. Imagine you're building a complex system. In an inside-out approach, you'd start with the individual entities and start fleshing out their behaviors at higher layers. Eventually, at higher layers, you'd start assembling individual pieces. Now, some might say that this assembly, this integration, is where the risk is, and that by definition should be cared for first. But before you get into the small and perhaps even meaningless entities that support the integration, you should care for that first, right? So I'd argue that it's easier to parallelize work on a team if you start from the inside out. People can pick a part of the application that they like to work on, and work streams converge at the integration tier, at the UI layer, the API layer, or whatever, higher up, right? I like to go inside out. I like to start fleshing out the little business entities and domain, and then start working my way out towards the interfaces, where in this case, interface could be for your API tier or your UI user interface or whatever. If you're just building an API, an HTTP API or an RPC API, then the API is the interface, right? In this way, I'm deferring potentially risky integrations until a little bit later, and hopefully in a microservices world, that integration is still rather small and controlled by folks on the same team. That is, integration isn't as scary if it's all being done by the same people or the same set of people on a small team. If it's a large surface area for integration, of course, there's a lot more risk. So it's up to you. For our purposes, we're going to do inside out, as I say. We're going to write a small service and then scale out and see what that looks like. So what we're going to do is we're going to go here to our start.spring. We're going to build a new service called a producer. Okay, producer. And here I'm going to use the latest and greatest version of Java. You should use Java 14 or 11, but definitely don't use Java 8. It's long since deprecated, no longer supported, past its prime, expired, old, stinky, fresh, not fresh. I mean, just a terrible choice today. So Java 11 is the current long-term supported version of Java. You should definitely use that. Or Java 14, that's the current supported version of Java. That's where you should probably go. That's where I'm going to go. But either way, Java 14 or Java 11, these are technically superior solutions. They're faster, they have more security, more robust, more syntax, more everything. They're also morally better solutions. Again, you're not going to enjoy that awkward conversation with your kids when they see that you're using Java 8 in production. The look of shock and horror, and perhaps even shame in their eyes, will steal you. It'll hit you in your heart. It'll stop you dead in your tracks. So don't have that conversation. It's not something you want to do. What we want to do is we're going to use the reactive web support. We're going to use R2DBC. We're going to use Lombok, and I suppose we want to use the Spring Cloud contract verifier. Okay, so we're going to hit generate. That's going to give us a new project. I'm going to hit generate. Oops, you know what I forgot? I forgot to add Postgres. Let me add a Postgres driver there. RM that, and now I hit generate, and I've got a zip file. I'm going to open this up in my IDE. You know what I just did there that I don't need to do? I unzipped it. I unzipped the zip file, and I have a little Python script that unzips it, and then it opens up the pom.xml in my IDE, which of course is IntelliJ. I'm a big fan, but you don't need to do that. If you're using the Ultimate Edition, you can go to File, New, and there's a wizard there, and that wizard then feeds into the same service, start.spring.io, as I just used. I'm just so used to doing it that way. But if you're already in IntelliJ and you're not worried about keeping one thing separate from the other for the purposes of presentation, then absolutely feel free to use it. All right, so public static void main. We're going to go to the test code here, and we've got a test class. This is one of the nice things about Spring Boot applications. It's you get a generated stub test class, right? And that's nice. But the test class is actually not a great test for what we're trying to do. So I like to just delete it, right? I'm going to delete it, and we'll start with our own thing. So the first thing we're going to do is we're going to build an application that writes data to the database in terms of an entity. And this entity is going to be a reservation. So I'm going to create a little test that proves certain things about that entity. Okay, so I'm going to create a little test here, like so. Test. Okay, do I have? Let's see. Come on. Oh, sometimes it's funny. I have to. Let's do this. Here we go. RMRF producer, unzip producer.zip, subl producer pom.xml. Okay, and I'm going to do this here. Get rid of that. Save, and then cd producer, and then ID pom.xml. Okay. Same trick. It's just that for some reason there's some weirdness there with I'm not sure what it is. I just need the class path to be imported a certain way. It's a fairly new development that it doesn't do the right thing. Okay, take 3. This time, here's our application. Here's our test. Again, we're going to delete that test. We don't really want the test, so we'll get rid of that. Goodbye. And we're going to build a test to test a particular entity. This entity is going to be called a reservation. So I'll write a reservation test class. And this class is just going to, this test is just going to prove certain things about a particular entity, about its ability to support fields and so on. So just, just creation, just a construction, not a big deal, right? A very simple unit test kind of thing. Not even a unit test, just a regular test, right? So reservation. And the entity is going to be called reservation. The reservation is going to have a field for an ID and a name. Okay, so there's that. Maybe it's 1, whatever. And this entity I'm going to create it here as a class. Okay, and so I'll create this class here. And the entity is going to have a constructor. You can see that that's a failing test, right? I need the constructor, so I'll say private integer ID and private string name. Okay, here we go. And there we go. That's our basic entity. Now I want the getters and the setters and the toString, so I'll skip ahead here a little bit and do that with Lombok. There's a nice plugin here for IntelliJ that just makes it work automatically out of the box. And there you go. That's my basic entity. It's going to have a primary key field there. And now I want to just prove that given that, I can actually get certain results that I expect, right? So assert equals reservation.getID equals 1, right? This is a very simple test. I'm sure you've seen tests like this before, not particularly fancy, but let's just see that that works. Okay, assert equals 1L. No, that's not it. That should be, what's the issue here? Oh, in long and it's an integer, so let's say integer. There you go. Okay, so run this and you should see that everything is fine. Now, I know that's going to be okay, right? We know that. This is a simple test, easy enough to understand. I do have it in the wrong package, though. Do that. You should put it in the right package. Do better than I did there. And from there, what I want to do is I want to then test the ability to write to the database. So I actually moved the test right out of the package midstream. So let me just try that again. Make sure everything's happy. Okay, seems good. So next trick, we want to test the database. We want to test that we can save instances of this type to the database. So we'll say reservation repository, okay, test. And this test class is just going to be a thing that tests our ability to persist instances of this entity to the database. So you can see what I'm going to do. I'm going to persist instances, and in order to persist them, I need a reference to a repository, right? And I haven't actually built that repository, so I'm going to go ahead and do that now. Reservation repository, there's this. I want it to be provided to me via Spring. I want Spring to give me a reference to that object. I could new up everything in isolation, but again, that's no problem. I understand that you want to keep certain parts that are invariant out of the test, and that's fine, but it's not such a big deal to, for purposes of testing the persistence layer, have Spring automatically give you the persistence layer and just the persistence layer. So what I'm going to do is I'm going to create this type, this reservation repository. In Spring, it's just an interface. So I'm going to create extends the reactive CRUD repository, managing types of reservation, whose primary key type is of type integer. And in order for Spring to satisfy that requirement, I need to say to JUnit to use the Spring runner. And I want it to just instantiate just the bits that have to do with running data code, data access layer code, right? This is going to be part of my data access tier, talking to my SQL database. In order for that to work, I need to configure some connectivity information. So I'll go to my application of properties, and I'll specify my R2DBC connection. So spring.r2dbc.url, R2DBC, and again, this is my username and password, friends. Don't tell anybody, okay? This is just our secret. I really, it would be very rude if you were to tell the world about my username and password. It's not great. So here we go, username and password orders. There's my simple test. Let's now see if it works. So what I want to do is I want to write some data to the database, delete everything there first, and then write some data, and then prove that I got the data back. So I'll say this at reservation repository dot delete all. Then I'm going to say write this new record. I'll say this at reservation repository dot save new reservation, passing in null, and then Jane for the name. And then I'll say this dot reservation repository find all. And if I'm not mistaken, that pipeline should have resulted in one result. Well, this is an asynchronous pipeline. It's a reactive pipeline. So even though I've used these deterministic operators, things may execute on different threads. So you must use the step verifier to be able to poke at the asynchronous result. Okay, so I can say, given a response, I expect that the reservation has an ID that's not null and that the name equals, ignore case, Jane, right? And if I, that should be enough to satisfy the predicate there. So let's run this and see if that works. Okay, something's clearly wrong. Okay, connection factory. Did I forget the driver? I got the driver, good. So I must have given it the wrong connection string. I sometimes get confused. R2DBC Postgres, is it QL? I never know. For JDBC, it's either Postgres, and for R2DBC, it's Postgres QL, or vice versa. I'm not sure. Either way, hopefully I've caught the error. No, doesn't seem I have. R2DBC. There you go. See, this is why it's good to have the tests. Okay, good. So we're good. Now I want to build an HTTP tier. So I go here, I say reservation HTTP test, right? And here, what I'm going to do is I'm just going to test that I can poke at my functional reactive HTTP endpoint. I'm going to say server, I'm going to say test public void get, okay? And in order to do this, I'm going to use the reactive web test client. Now, back here, you saw in my test code for the repository, I used an annotation. This is called a test slice. It's only going to stand up the bits that I care about concerning a particular slice of functionality. Here, I'm going to use the WebFlux test, okay? So I'm going to run it with the Spring Runner, but this is only going to stand up the web tier components. And I can use this test client. I can say .get.uri HTTP localhost 8080/reservations, right? And then I'm going to say that I expect the data to come back, and I expect there to be a body, and I expect the body to have a JSON structure that matches this JSON query, right? So is equal to Jane, right? So that's my total. This is me poking at the structure of the resulting JSON. Let's confirm that this works. It's going to fail, of course, because I don't have an HTTP endpoint. So I need to now go write the production code to make that work. And I can do that here. Let's see, this reservation should be here as well. Good. So we go here. Now we're going to create a reservation HTTP configuration. And this class is just going to be a Java configuration class. It's a Spring configuration class that registers a functional reactive HTTP endpoint. So server response, HTTP return route .build .get /reservations request server response .ok.body. Now, the collaborating object that we need, of course, is the reservation repository. So keep that in mind, right? We're actually injecting a reference to a data tier thing called the reservation repository, which we just stood up and which we already tested earlier. So why would we want this present in our web test, right? We clearly need it because it's a dependency on our web tier code, and yet we don't want it because it's an invariant. We've already tested it. We already know it works. So what I want to do is I'm going to mock it out, and I can do that pretty easily here with mock bean. So private reservation repository like that. And that will tell Spring that if this type is present as a bean in the repository, great, replace it. And if it's not, then use the default that I'm providing here. And all I'm doing is I'm providing a new reservation with a default value that I can then trust. So this is a Mockito instance, right? It's going to be a mock bean, but it's going to be something I can program. A stub is basically a thing that acts to return nulls, right? What I want to return nulls and also have certain pre-programmed behaviors. So what's the malfunction here, friend? Filter reservations exchanged localhost 8080 expect body JSON path. Did I not do that correctly? Find all reservation, find all. Looks fine to me. So filter can only apply to. Oh, that, you know what it is? I forgot to bring in the class, so it doesn't know about that endpoint. So I'm trying to assert something about the JSON that's coming back when there is no JSON, right? So reservation HTTP configuration, take 3. Reservation. So what's the issue here, friends? Reservation HTTP test, localhost, returning 1. Let's just try that, see if that makes it better. And then the JSON that I'm expecting here should be when in doubt, check it out. So cat desktop, Bootiful testing. Okay, and we want the producer, source, test, Java, com, producer, and reservation, HTTP test, 0, yeah, is equal to, let's just cheat just in case. Can't afford to lose it just because of a syntax error. Looks to me to be the correct response. So that's a test class, WebFlux test. Import That's what I did wrong. Where did I put the other one then? So it's over here. I could have sworn I just did this somewhere, but okay. I'm going to import that. And good, so that's working. That's fine. So we've got a data access tier, we've got a web tier, we've got a repository. Now let's create a client to talk to the service. So we go back to start.spring.io, and here we're going to build a client. Going to use the reactive web support. We're going to use Lombok. We're going to use the stub runner, and we're going to use. I guess that's it. I'm happy with those selections actually. So this will be a thing that will act as a client to talk to our service. I'm going to hit generate, and I'll go to my command line here, downloads. Okay, unzip client.zip, cd client, subl pom.xml. Go down to the bottom here, just remove this bit right here. I'm using JUnit 4 for purposes of backwards compatibility. By default, you get JUnit 5. So idea pom.xml. And what I'm doing is I'm going to build a class that actually talks to the service that we've just built. Now, this class is going to be a simple client. Okay, so I'm going to go to my test, and here, it's not such a big deal to use the default one because we're just going to be doing one simple thing, which is get all reservations. And we're going to do that by injecting a reference to a Spring Bean called a reservation client. Now, of course, this class doesn't exist here yet, so let's do that right now. Now, this is going to be a Spring Bean again. Spring Bean that in turn depends upon a web client, a reactive web client. And we're going to inject that into the constructor, so we can use Lombok there. And we're going to return a publisher of the reservation data. So get all reservations dot get dot HTTP, and then it'll be a local host, right? 8080/reservations. And the data that we get is going to be coming back, and it's going to be JSON. And we want to convert it into a type of DTO, right? Well, we have to create that DTO here. So I'll do that right here. I'm going to say reservation private integer ID private string reservation name at data at all args constructor and no args constructor. Okay, so there's the basic flow, right? There's the basic client. Here's the test. So we say step verifier dot create this dot client dot get all reservations. Expect next matches r dot get ID. It's not null, and r dot get reservation name equals ignore case Jane. Right. So same as before. Basically, there's only a problem. There's only a few problems with this. First, I don't have a reservation client, web client. I didn't create a web client anywhere, so I need to new up that bean somewhere. So I can do that in the client application context, right? For example, right here, tell Spring to create the reactive non-blocking HTTP client. So I can use it to make the network call. The other problem we've got, and this is much more sinister, is that I'm not running that service. I'm not running my HTTP service, and so this web client this test isn't going to work, and that's the problem, right? In order for me to test this client, I now need to stand up that other service, and that's no way to run a railroad, right? That's very unfortunate. Nobody likes to be told you must deploy this Kubernetes cluster just to be able to test your little service in isolation. So what we want is some way to mock out the dependency on the network service, just like we can do for Java APIs. And one thing I could do is use wiremock, right? I could say auto configure wiremock, and then just do a wiremock test like this. I can say stub for wiremock, and so on, right? I can do that if I want. But what I really want to do is I don't want to use wiremock, because wiremock creates I synthesize the API here on the client, but there's no guarantee that the thing I mock out will look like the thing on the service side, right? So a better way is to go to the producer here, and in the code, introduce a contract. Now, a contract is a file that gets transpiled into a test that actually runs against your working API. Okay, so I'm going to create a Spring Cloud contract. I can use several different DSLs. I'm going to use the Groovy one. You can also use Kotlin. You can use Java. There's a property file or YAML file version of it. Lots of different approaches. The Groovy one is the most well known, so I'm happy to lead you to this one first. And it's just a assertion of all the things that you expect given a given request and a particular response. So I'm going to say that a request going to this endpoint will be going to the URL /reservations, and I expect it to have this particular HTTP method, right? HTTP method.get method name, and I expect the response to have a status code of HTTP status .ok .value. And again, nice thing about IntelliJ is that I'm using Groovy, and I can use Groovy, Kotlin, Java, all in the same thing. It just kind of works. That's pretty cool. The body will be I expect the body to look kind of like the following, right? And again, this is going to get transpiled at compile time into a test. And so that's where we actually get into, we have to actually modify the build here a little bit here to make that work. So content type, I expect will be media type dot application JSON value. Now this is a Groovy contract, but something has to enforce that contract, right? That's where the build comes in. So the build, I need to customize that here a little bit. The test, I'm going to say that this is an explicit test, and I'm going to provide a base class. So what I've just done is I've just created a test. This is going to get transpiled into a test, but it doesn't know anything about a Spring application context. It doesn't know about a functional reactive HTTP endpoints. It doesn't know anything. So we need to give it a base class that it can extend at compile time, that in turn knows how to set everything up for us, just as I did for that HTTP test earlier on. So I'm going to create a base class here in my test package called, imaginatively enough, base class. And this base class is just going to just do all the kind of things that we just did, right? So, before, public void before. And this base class lives in com example producer base class. So I'll just say com example producer base class. And what I'm going to do is I'm going to make this a Spring Boot test. I'm going to run it with the Spring Runner.class. And I'm going to need to do a few things. I'll inject the current port of the application, and I'll mock bean out, just as before, my reservation repository, right? So this will give me the same benefits as before, and I can now configure the framework so that it knows where the requests should be directed. So this.port, and I'm going to also do same as before, mockito.when this.reservation repository find all, then flux.just new reservation one Jane. Okay, so just providing us a stub. Okay, good. All right, so I've got now a simple base class. I've configured my build to know about it. So let's see what happens if I actually run this code. Okay, so Maven clean install. Uh-oh. Test failures, imagine. Let's see. Bean creation error. Okay. So I can already kind of guess what that is. I forgot to bring in the HTTP components, right? So reservation, HTTP configuration, same as before, I think. Let's try that. Uh-oh, again. Okay, so this is the other thing. I want to run this on a random port. So I'll say web environment equals random port, right? So there's this. Good, try that again. Okay, good. So it worked. I installed the test. I did Maven clean install, and you can see that it actually gave me a few things. It said it's going to install a jar, right? Up here it installed my Maven metadata. Sure, good. It's also installing a stubs jar. That's the interesting bit here. And it installed a regular jar. So in here in this output, you'll see 3 different things that got installed. The most important of which is a stub. That stub contains a definition of the API. That API, you can see, was generated for us. That contract was transpiled into this test. So contract verifier test.java, cat this file. And if you look at the code, if you look at the output there, it's actually a simple class that extends our base class that says given an HTTP request to / reservations, assert that it has status code 200, this content type, this, and that the structure of the resulting JSON comes back as such. Now now that we've run that test, when we build our producer, it gets installed into our local Maven repository, or more likely at the end of continuous integration environment run, and into your Artifactory or whatever your artifact management repository is, right? Now it's available to the rest of the organization. So now here on the client, on the consumer side, I can then pull that in to test my API, right? To test this client. So I'm going to say auto configure stub runner. And here I'm going to give it the coordinates of the artifact that I just installed. So the coordinates are the Maven coordinates, right? The Ivy, Maven, whatever coordinates of the build. So if I go back to here, excuse me, I go here, it's com example producer, and I want the latest version. So com example producer. Okay, that's the artifact ID. Sorry, that's the group ID. That's the artifact ID. That's the version and the port on which I want the stub to make itself aware, make itself available as an API that's running on a local host, is on port 8080. So what it's going to do is it's going to take that contract and turn it into a WireMock definition, which I can then use to actually to stand up a mock API version of our network service. Okay, so now let's see if this works. Now that we've done all that hard work, right? I'm going to pull in that thing I just installed into my local Artifactory. Run this. Aha, so there is something wrong. I've introduced a bug somewhere, haven't I? So you can see what I did here. It is said, oh, it says it doesn't know where to find the stub. So I need to say stubs mode equals local, not class path, and not remote. It's not looking at my remote ones. It should be looking on the local M2 repository, since that's where I installed it by default. All right, we cut a bug. There's a no pointer, and I think you can guess where. You see, earlier on, I wrote this code, and I created a client-side representation of the type reservation. I use reservation name instead of name. That doesn't exist. That doesn't match. So now, by using contract testing, I've actually managed to catch a bug in the network protocol as opposed to in the Java interfaces, right? So I've created a sort of a contract or an interface for my remote service, and I've done so at test time, where it's much cheaper to catch it, and that doesn't require any extra metadata at runtime, right? So it's much better to catch this stuff at test time. All right, my friends, I hope you learned something. I hope you got something out of this. Today we've looked at the motivations for testing, for test-driven development, for why we want to go faster and get better cycle time. We looked at how to test, to do unit testing, how to do that with Spring. And you can see that out of the box, you get all this stuff for free. You get Mockito and JUnit and all that good stuff already provided for you out of the box. It's not even an option to uncheck that particular checkbox. And then we looked at testing HTTP endpoints, and we looked at testing repositories. All this is reactive, mind you. And then we looked at the problem of when you move to microservices and you want to test one service in relation to another. And we looked at how to avoid the very awkward conversation you have to have with a new colleague that comes to join your organization, whereupon you instruct them that in order to be productive and just to be able to test your one application, they need to deploy this whole Kubernetes cluster. It's not a good look. Nobody's going to like you for that. Nobody's going to want to be your friend, and it's not cool. It's not cool. And can you imagine being an iOS developer, an Android developer, or whatever, and somebody says, "Here, deploy these 500 virtual machines just to be able to test your Android client"? Not great, right? Now you can get around that. This stub, by the way, the stub that we just looked at, is also, you can run it. So there's actually a Spring Boot stub runner jar you can download. It's just a little jar. You run Java jar, stub runner jar, and then you give it the coordinates, just as I did for that annotation, and it'll create the WireMock service for you as well. So you don't need Spring Boot to be able to get the benefit of that WireMock based API. So by testing your code, you also get the stub that everybody in the organization, if they're doing the HTML5 client, or if they're building an Android client or iOS client or whatever, they can all now talk to your service or to a version that we know is exactly the same as your service because it was tested and built when your test was green and deployed into Artifactory. So really, really big win there. I hope you got something out of it, friends. Thank you for your time. Thank you, Trisha and Mala. Thank you so much. Great to see you both. Sorry I ran so long.
Hi, Josh. Thank you so much. It was an amazing session. We received a lot of comments on you were going too fast
Uh-oh.
because I know it could be difficult to follow what you are doing because I know you code quite fast. So, and the other point was it was lovely to see you debugging your applications because this is how we developers work. We know things go wrong, and of course, we have to debug that. So, we received a lot of comments on that part as well, that people they really liked how you were debugging your application live. And of course, when you are doing a live demo, I think that is a part of it. Something has to go wrong, right?
Right. Well, I'm glad we got through it.
Yes.
Should I
uh,
answer some of these questions?
so I have the questions for you. So one of the questions was, do you have any reason for not using JUnit 5?
No, just most people have JUnit 4, so I didn't want to be. I didn't. I could have used Kotlin for this. I love Kotlin. I just don't know what the audience would be for this wonderful, wonderful event. So I'm just trying to get the widest swath of people that'll get productive as soon as they leave this talk. Somebody asked me about. I saw one very important question here, which is that somebody said that they like the Nyan Cat plugin. This is one of the reasons people should be using IntelliJ, because great plugins. There's a Nyan Cat progress bar plugin, which makes my day great every day.
Great. And the other fun question was, people are asking how to become a magician like you.
Just make friends like you. Learn from smart people like Mala and Trisha who can teach you. That's how I do it. It's the only way to get. It's the only way to get to production quickly is just to ask smarter people for help. And we're very lucky for events like this, actually, aren't we? Events like this that bring people that are, passionate and capable together.
Yes, and I also noticed that you were using Lombok in your code. So did
Yep.
you try out records as well, or because you have been used to using Lombok, so probably that was the reason you used it?
I did. I love record. So I did a Spring Tips video. I did that in my YouTube channel, Spring Tips, bit.ly/spring-tips-playlist. I did a Java 14 and video, and all of the features I looked at were basically previews, right? So records and multi-line strings and var and smart switch expressions and all these great things. Yeah, Java 14, all those preview features starting to look really close to Kotlin. It's like starting to get to the point where if you squint and don't look at it too closely, yeah, these two languages are really Java 14 is really compelling, right? And I know you've got certification books that are people should be looking at if they want to understand all the new stuff as well. I certainly will. Yeah, I love the records in Java 14. Yeah.
Thank you so much. The other interesting question is, how about negative cases of contracts? There are a million negative cases, and how a contract may be broken, how to make up for that.
A million negative cases and how a contract may be broken. I'm not too sure, but yeah, I don't know. I'm sorry. I like contracts can be, maybe they don't support what you're trying to do. I don't know I'm not sure if I understand the question, let alone how to respond to it. I would say that contracts, as I've used them, are so far just for HTTP, but Spring Cloud Contracts also supports messaging, so Kafka and RabbitMQ and whatever. So there shouldn't be a lot of places where they don't serve your use case, as far as I understand.
Okay, the other thing that I have noticed in a lot of other talks as well, that you use Groovy and Kotlin as well. So
Yep.
would you have any recommendation where people should be using Java or Kotlin or Groovy, and probably the best use cases for using all the three of these languages? Because yes, we know that we can use them on the JVM, but what would be places that you use, and what would you recommend?
Well, so if you're asking me, I don't know anything, but I use Kotlin for my own personal stuff. Any kind of software that I'm writing to scratch my own itch, I use Kotlin, right? So I use Kotlin because it has the second largest community in the JVM space. I use it because it has it compiles really quickly while still giving you more syntax than Java has at the moment, right? So like with Scala, Scala's got even more syntax. You can do everything in Scala, but compilation time is problematic, right? So for me, Kotlin is a very nice, happy medium. It's just it's fast, but I also can get features that feel like Java 20 or Java 30 or whatever. As to when you should use Java, I mean, obviously, if you've got if you've got a project that's Java right now and it's a big one, the move to Java 14 is going to be way easier than to Kotlin, right? But the tooling, that's fair, right? Is that fair? Even with the amazing tooling from JetBrains, it's going to be a harder move. But on the other hand, these are JVM languages, so maybe for new projects, you start with Kotlin, right? I would certainly start my new stuff with Kotlin. I'm doing that. I'm not going back and refactoring everything into Java because there's no need. But JetBrains even has this very nifty feature. I don't know if this is in the community and stuff, but probably this very nifty feature where you can copy and paste Java code and get it translated into Kotlin. So
absolutely, you're right.
Very convenient. And as for Groovy, yeah, use that. That's a very nice language too. You can use it with Gradle, right? If you want. That it's everywhere. It's still there, very pervasive. But it's I use it in the contract. The Spring Cloud contract DSL for Groovy is the oldest one, so I use that because it's common. But there's a new Kotlin one, and I should use that.